Okay, dear student, let us see what is there in this question. Airboats are used for transport across a river. To move the boat forward, air is propelled from the back of the boat by a fan blade. Okay, the side view is shown here, and this is the top view. An airboat has a fan blade of the radius 1.8 meters. This fan can propel air with the maximum speed relative to the boat of 20 meter per second. The density of the air is to be taken as 1.2. Outline why a force acts on the airboat due to the fan blade. Okay, so first of all, what happens here is they are just using action reaction principle of like Newton's third law. So what is actually happening here is this is the fan, and fan is trying to propel the air into the backward direction. So because of this action force, a reaction force comes into play, and that reaction force is giving a force on the boat. It is applying a force on the boat, and so the boat starts moving towards the right hand side. So this is kind of we can call it reaction principle, or you can even call it rocket principle. It's actually the same thing. Okay, and so there is a mass flow rate in the backward direction towards left hand side, which creates a reaction force. Now let us see what is the answer given by them, by IB, for this question, because this is completely theoretical question. Understanding is one thing and writing is another. So in these kind of questions, my advice to you is always to refer the mark scheme and see what is it that they want you to write. Okay, let's see. So here it is. There is a force by the fan on the air, and air is accelerated to the rear by Newton's third law. There is an equal and opposite force on the boat. Exactly the same thing, but they have written it in a different manner. Like they have clearly written that there is a force on the air by the fan, and the reaction is there, which will be like the force on the fan or the boat by the air. That will be the reaction part, which is going to be equal and opposite, which is going to push the boat towards the right hand side. So exactly the same thing that we discussed earlier. Let us move to the next question now. In a test, the airboat is tied to the river bank with a rope normal to the bank. The fan propels the air at its maximum speed. We just assume it. And there is no wind going on. Show that the mass of about 240 kgs of the air moves through the fan every second. So we want to find the mass flow rate here. And in these kind of cases, one thing is clear. Like I have a couple of formulas here. Let me give you those. So the first is rate of flow of mass. These formulas are used whenever there is a windmill kind of apparatus, and these formulas are used for windmill actually. Okay, so the same thing is being used here, and this formula is rho av. The students, those who have option B as their optional, like engineering physics, they have fluid mechanics and that. And in fluid mechanics, they have seen continuity equation. This is exactly the same thing. So continuity equation tells you like what is the mass entering the pipe and what is the mass leaving the pipe. Similarly, in this case, like we are just assuming it to be a pipe. So the diameter of the wing is acting like a pipe, and the wind is blowing in, and the air is going inside of it. So we are using the same formula. So the rate of flow of mass is given by rho av. You can clearly see rho is the density. The unit is like kg per meter cube. Area is meter square, and the velocity will be given by meter per second. So everything gets cancelled out. So overall, the unit becomes kg per second, which is rate of flow of mass. What is the rate at which the mass is moving out? That is what we want to find, like 240 kgs in 1 second. This is what we want to find. So we just plug in our value and get the answer. So the density was, I have to go 1.2. Okay, let us do it here only. So the density will be 1.2 kg per meter cube, and rho av. What is the cross sectional area? Pi r square. Radius is given as 1.8 in meters, and the velocity of the wind is 20. Relative to the boat, the wind is going backward with the speed of 20. So we will write this. This will give us the answer. And let's see if they are doing the same thing. Or yeah, let us see the mark scheme. Okay. Well, exactly the same thing. Pi r square is the cross sectional area, and the mass flow rate per unit time, like mass flow per unit time, it is given by rho AV. So I am writing it rho AV, they have written AV rho, one is the same thing. And it is coming out to be 244 kg per second to be exact. So 244 kg per second to be exact. And earlier they were saying that you have to prove that it is near, approximately it is 250 or something, 240, yes. Okay, so this is how we do it, and this is one of the formulas that you have to remember. I would be telling you the other formulas also. I believe they will be asking the other formulas also in the question. We will see. Okay, show that the tension in the rope is about 5 kilonewton now. So what is the tension in the rope? So tension means force, and this is the second formula which is related with the windmill. So the force applied on the wind, on the air by the blade, is equal to the force which is applied by air on the wings. And so that will be the force, and obviously that will be equal to the tension, because the boat is actually not moving. So it means that the tension in the left hand side direction will be equal to the propelling force which is in the right hand side direction. So for the mass flow rate, we have already seen that the formula is given by rho AV, and for the force, the formula is given by rho AV square. That's a direct, straightforward formula, and it is basically the change in momentum. So change in momentum is taken from this. I can also write like reaction force F is equal to V into dm by dt. This dm by dt is rho AV, so it is velocity into rho AV. Overall, the formula becomes rho AV square, but you can even remember this. Just plug in the value and get the answer. This is the formula for the reaction force. I have given all of these things in detail um, in my online course for this topic, Newton's laws of motion. So you can refer to the online course also if you want to see all the topics. Okay, so this is the formula that we do, that we apply here. Let's see if they have done the same thing. So the force is equal to momentum. Yes, so the formula is rho AV square, exactly the same thing, and answer is coming out to be 4.9 kilonewton. That's it. So 4.9 kilonewton is the total force which is uh, applied on the boat, and the boat is trying to move, and the string is tight now. So what is the tension in the rope? And that is also equal to 4.9 kilonewtons. And this is about the 5 newtons. So this question is done. Let us now move to the next. There will be only one last third formula that is left. Are they talking about power somewhere? Let me please verify. Just a moment. Deduce the mass. No. So I would be giving you that formula now. They might not be using it, but let me show you. So there are three formulas that I have given you. First is about the mass flow rate, which is rho AV, and then there is force, which is rho AV square, and then there is another formula for the power, which is 1 by 2 rho a v cube, which is derived from the change in kinetic energy of the wind. So we would be doing that in when we will be going for the windmill. So overall, you can just note these formulas, that wherever you need, there is a fan which is working or a windmill which is working, these are the formulas which you can apply directly. Two formulas we have already applied in this question. Third, we will see if there will be need, we will apply, otherwise no problem. Okay, so this is done now. The rope is untied and boat moves away from the bank. The variation with time t of the speed is shown. So now he's talking about the terminal velocity, by the way. So we would be working with a constant force towards right hand side, and obviously there will be a drag force that will start acting on the boat, and more is the velocity, more becomes the drag force. Gradually the drag force will become equal, and will become equal to the forward force, and the net force will become zero. Thereby the acceleration will become zero, and hence the velocity will become constant, and this is what exactly is happening here. So you can clearly see here that the slope is very high, and the slope will be kind of acceleration, whatever it is, and then it keeps on reducing. Slope is the acceleration, so you can clearly see that the slope is reducing. Here the slope becomes 0. So the terminal velocity is given by 18 meter per second. This is the terminal velocity that is attained. Now let's see what is the question. Explain why the airboat has a maximum speed under these conditions. So we have already explained it, because there will be a concept of drag force which is directly proportional to the velocity, and after some time the drag force will increase, and it will become um, equal to the forward force. So they will cancel each other, and hence the acceleration will be 0, and hence the velocity will attain a maximum value, and then it will become constant. Why? Because acceleration is 0. So we will see the mark scheme later. Estimate the distance the airboat travels to reach its maximum speed. So we want to find the distance until it reaches the maximum speed. Now, these are like very different questions, which I have not seen these questions in any other examination, but in IB. So what happens is, like, we need to find the distance here, but the curve is not given, nothing is given, so it will be equal to the area under the VT curve. And the area under the VT curve from this, like this whole area, we have to find. So how are we going to find it? We have to count the number of squares. Yes, you heard it right. We have to count the number of squares. We will be quick. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. 47, just like that. Okay, so we will find all the number of blocks, like whatever blocks they are, and we will find the area of this first square, this one. So that will be 2, this is 5, both are SI unit. 5 to the 10, so this is the 10 meters distance. So whatever number of blocks we have, like let us say we have 46, so let us say 50 blocks, so 50 into 10, so our answer will be 500 meters approximate. So let us see the mark scheme, what they are doing. Well, here you can clearly see C2, recognition that the area under the graph will be distance covered, and the distance, a very big range is given. On an average, we got the answer of 500, and they have given the range from 480 to 560. So you can answer anything, and you would be getting the marks. So this is how you do it. At the end of the day, you have to find the area, or you have to find the number of squares there. Now, what is C1? Resistive forces increase with speed. So resistive force equal, it becomes equal to the thrust, and so the net acceleration becomes 0, and hence the velocity becomes constant. Exactly the same thing, the same explanation that we have taken earlier. Let us now move to the next question. Deduce the mass of the airboat. Deduce the mass of the airboat. Okay, so we have to find the mass of the airboat. So how can we find that? The mass of the airboat. I think the mass of the airboat can be found by using a formula that is F is equal to m into a. I don't think that there is any other formula that we can even use here. So what we do is, we will find the acceleration for the initial hours. This acceleration multiplied by mass should be equal to the initial force when the drag force was 0, and that should be equal to the force that we found earlier, that is rho av square in the upper question. So we found this force, we will equate it with m into a. Acceleration will be taken as the slope of the VT curve. So from this we will find the slope also, and accordingly we can find the mass. Okay, so let's try to do it. So what will be the slope now? So this is almost a perfect point. 1, 2, and 1, 2, 3, 4, 5. So this is also 2. So 2 divided by 2, like 2 is this, and this will be 2 in the seconds. So the angle will be 45. So tan 45 will be 1. So m acceleration is 1. And what was the force that we found earlier? I'm just yeah, it was 4.9 kilonewtons. 4.9 kilonewtons. So 4.9 kilo, it means 4900. Yeah, so mass is 4900 kgs. That will be the answer. This is how we do this question. And let us see the mark scheme. Yes, the answer is 4900. And is there any other question? No, the question number 2 is coming. Okay, dear students, so this is how we do this question. This is the first question for this question paper. Thanks for watching the video. Please share the video with all of the students. See you in the next video.